G'day there, you're watching the Aussie Boom Guru, and today I've got a quick video to run through a user request I received recently from a viewer through my Gmail. So they were requesting how to get real world coordinates, so X and Y coordinates of in this case, the location of a cable pit. I'm just going to show you how you can convert between the Dynamo and the internal coordinate systems. I'm going to be using a custom package to do this, but it's all exposed Python code from the Genius Loci package. So to begin with, I'm just going to be in this particular sample model. I'm going to expose all three origin points. So by default in Dynamo, the origin will be sitting at the internal origin point as 0, 0, 0. As well as this, it's going to be always orientated towards the y-axis of the internal origin system. So this isn't always going to be aligned with the real world coordinates of the project. So let's say I want to get all the coordinates at the top of the caps of these piles, which is quite a common thing we need to do when assisting a setup process. By default, I wouldn't be able to do this. So in this case, I'm just going to edit this family just to give myself a point I can snap to, just to indicate the points we're going to try and get real world coordinates of. I'm just going to put a line in the family for now, just a 3D model line. And in this case, we're going to want to be spot coordinating, well, capturing the point here. So what I'm going to do is just isolate these two, and effectively we're trying to capture these coordinates for these particular objects. Now what I might also do is just modify the coordinate system to make it a little bit more complicated. So here, for example, the project base point currently has an elevation of 0. Let's say instead maybe the project base point has a different elevation to the internal origin system specifically. So the internal origin system isn't sitting at Z as 0 either. I'm going to specify coordinates on my base point, and let's say that this is actually at 5 meters, this is at -5 meters, and this is at -10 meters. As well as this, generally I recommend that in most setups you would want to set up a relative marker at 0, 0, 0, namely in this case being our survey point. And we're going to be utilizing this point in order to create the coordinates at these particular objects. So I'm just going to jump into Dynamo. It's actually a fairly simple script, nothing too complicated. So I'm going to make a new script. So the first thing we want to do is actually get the model elements that we would like to actually report the coordinates for. So I'm going to just isolate these and select them in Dynamo using the select model elements node. And we're going to try and get the point at the top of them. Now this may not always be the location of the family, so you can use get location, but it's going to be the origin of the family. Now in this case it happens to be correct in this particular family. However, sometimes you may need to use the bounding box of the object to get the topmost point instead. So if we do need to do that, I'm going to get the element aligned bounding box. And then from this bounding box, I'm going to get its minimum and its maximum point in its axis aligned system. So what we're going to have in Revit at the moment is basically the top and the bottom corner points of the bounding box, and we can use these to find the center top point of this object. So I'm going to take these two and I'm going to start building a code block. And I'm going to say in this case that we're going to find the middle X and Y point. So the formula I'm going to use for these is going to use the minimum and maximum X and Y points. So first I'm going to target the X. So I'm going to say that we want to take the minimum X. Now that's a really annoying behavior that sometimes this process has when you use the X command. It always assumes a completely different thing. So I am going to be working around this here and there. So I'm going to add to the minimum half of the difference from the maximum to the minimum. And that will give me the X coordinate between those two minimum and maximum points. Likewise for the Y, I'm going to be doing the exact same thing, but just now I'm targeting the Y property. And now we know that we're just targeting the maximum Z. So in this case, max refers to a variable for the maximum bounding box point, and min refers to the minimum point variable. It's not like a special word. You can call this whatever you want. I can call this max with 2 X's, and you can see I now have 2 options for variables, but I've just chosen to call them this just to keep things simple. So in this case, what we can do from this is construct these back together as points with the X, Y, and Z components. I'm just going to turn off the preview for these bounding box points. And assuming this has worked, there they are. So we can see now we've got the top of the objects in the middle of the object. So that's another way to get those points if you need them. So now we need to actually get those points in a converted coordinate system. So I'm going to be using the Genius Loci package in this case. It has some great nodes, and it has one that is currently called Real World Coordinates. I believe that should be, in this case, in the Genius Loci package under Geometry, and we can see it's this node here in this case. This will take a point and then return that point in different relative coordinate systems, which we can then ask the coordinates of. So I can provide a point. It will firstly try to check its X and Y and Z values in the survey-based system, the project-based point-based system, and the internal origin system. Now in this case, because we're coming from the internal origin system, we wouldn't expect that to be different, but we will expect the relativity of the other points to be different. So in this case, it is using some Revit API. I'm not going to go into too much depth in explaining it, but in this case, effectively, it's using transforms. So it's getting the project location class, getting it as an object, getting its transform and applying an inverse of that transform to these points in order to transform them basically based on the difference between those coordinate systems in Revit. It is a little bit complicated. It's probably not going to make a lot of sense if you don't understand the geometry in the Revit API, but it is all there to learn from inside this node. So thank you to Albin for his great package, as always, a very useful function. So I can take those points. Now you are going to get points in fairly arbitrary locations in the model, but you can ask these their coordinates relatively, their X and their Y components. So I've turned off the preview, and we're actually going to ask for the coordinates in the survey-based system. So the X coordinate is going to be the east and the west component, and the Y coordinate is going to be the north-south component. So what I can do now is construct basically a parameter setting process, where I'm going to write these values to two special parameters that I need to add to these objects to store this value. So before I do anything else, I'm going to go back to my model, go to Manage Project Parameters, and I'm going to add a project parameter, and I'll just call this North-South Manual. And we'll make it a length parameter of the instance type, and we'll just apply it to everything we can for now. And then I'm also going to create one called East-West Manual. Likewise, length, instance, everything we can. This will provide two parameters that we can store these coordinate values into in Revit, which by default isn't possible. Now, if you're going to want to tag these, you may want to use shared parameters instead. That way a tag can extract these values. Probably my recommendation if you are using this type of workflow quite regularly. But anyway, what we're going to do for now is go back to the model, given we have these parameters now. And I'm just going to make another code block, and I'm going to be getting two things in lists. So the first thing I'm going to say is East-West Manual and North-South Manual in a list. So we have the two parameter names, and then I'm going to get the two lists of values by asking these points, which I'll call P, for their X value and also their Y value, and put them in a list as well. So I'm going to ask for them in the survey system, and we can see that our second input is now going to be two lists of values. So we're going to have a list of values for a list of elements per parameter name. So we're going to be using list levels in order to save some time here. I'm going to be targeting a set parameter by name. I'm going to switch to manual. So I'm going to take my original objects. I'm going to be applying to these parameter names these lists of values. So in this case, we're dealing with a list of elements, so level 2. We're dealing with one parameter name per list of objects, so in this case level 1. And now I'm dealing with a list of values per parameter name, so level 2. So it's going to work across the values for the elements per parameter name. I'm now going to switch this to longest lacing. I'm going to run my workflow. And assuming that's worked, we should now find some coincidence between these values and what's been written. And we can see, sure enough, the North-South Manual and the East-West Manual line up to these components. So we've now successfully extracted real-world coordinates into these objects that can be scheduled. If you do want to tag them again, you're going to have to make a shared parameter so that it can be used in a tag. Actually, let's just do that real quick. I actually would prefer to show that. So what I'm going to do for now is just remove this north, south, and east, west manual parameter. I'm going to make a new parameter, but I'm going to make it a shared parameter. I'm just going to create a new shared parameter file and just call this temporary. Now you should ideally have like a shared parameter file that you can work with, and I'll just call this temporary, but you can add these to your shared parameter file, and I'll just say north-south manual. So really just doing the same process again, but now these are shared parameters, so they can be referenced outside the project. So this first one, again, applied to everything I can, and east-west manual from a shared parameter instead. And then I'm just going to make a new family, and I'll just make a generic tag annotation. And it can be a structural foundations tag. It could be a actually let's just do a multi-category tag, screw it. New family, and I think there should be a multi-category tag type in there. There we go. Because you'll probably be tagging all sorts of objects with this information. I'm just going to create a label, and in this case I'm going to reference that shared parameter, which I can now. So I'll take firstly the north-south and also the east-west values. I'm going to put a line break between them. The prefix for this will be north-south : space, and then east-west : space. We're probably going to want to justify this to top left or center left. It's up to you. Let's just say for now, actually, the vertical is going to be middle left. So I'm just going to save this tag, and in this case just call this coordinate values tag. Load this into my project and close. And because I need to tag in 3D, I'm going to lock my orientation. And I'm just going to go back and rerun this workflow. Come on. I'm just going to save this, coordinates 2. And now that these shared parameters are present, the workflow should still work the same. I really don't like this message in Dynamo. Hit run. It's now going to target those shared parameters instead. And we can now see that we've got those values in the shared parameters with the same name. But now I should be able to tag with a multi-category tag those values as well. And there we go. We can see we've got the same values coming out for those objects. And likewise, we can also schedule these values. So if I go to make, say, a structural foundation schedule, I should be able to add the north, south, and east, west values to these various structural foundations. Not sure if there's really another logical field in here at the moment to use, but if you had other information, you can schedule these alongside. Now, if you only want to show things that have valid values, you can always say that north-south has a value and east-west has a value. And you can see now I'm able to schedule that information per object. So it's quite a powerful little workflow, and that custom node from Genius Lyco it makes it really easy to do. And I hope it's been a useful workflow and helped address that user query as well. So if you're not already following and subscribing, feel free to do so. You can find the scripts I build on my GitHub if you're looking for them. So if you go to my GitHub, Aussie BIM Guru. I have a Dynamo repo, and I'll put the Dynamo script in here for that as well, with a date roughly around the time that I made this video. So like I said, if you're not already following and subscribing, feel free to do so, and I look forward to seeing you in future similar videos. Thanks. Take care.